Hello and welcome back to this series on Python and really kind of text classification for anyone who's interested, but specifically geared at those with limited coded experience like digital humanists. In this video, we're going to continue on with what we talked about in the last video, but instead of talking about something conceptually, we're going to start implementing it. And what we talked about in the last video was how to try to create automatically a training set using word vectors. Now, there's a couple different ways to automate the collation of a training set. You could use keyword searching across texts, so come up with a list of keywords that kind of, if they appear in a text, then that text should be classified as X. However, we know as humanists that sometimes language can be a little tricky, and sometimes words that are used to describe a specific thing might not be words that we would necessarily think about. So this video is geared at trying to think about words conceptually using word vectors trained on a very narrow corpus. And so what I'm going to show you in this video is first how to create those word vectors, then how to search those word vectors, and finally how to use those search results to create a list of words that meet a certain kind of conceptual topic. And in this video, we're going to be looking at specifically the topics of hunger, and we're also going to be looking at the subject of smell. So we're going to try to create a text classifier to be able to look at a document and tell you how much it's dealing with the concept of hunger and how much it's dealing with the concept of smell. That's going to be our challenge in this video. The data that we're working with is in this OCR folder. It's a bunch of oral testimonies from the Holocaust that I've OCR'd through Tesseract, and that's going to be a different video that's going to start coming out hopefully in a couple weeks in April of 2021. So let's go ahead and just kind of jump right into what we're going to be doing in this video. Let's go ahead and import glob. We're going to be using glob to iterate over all of our OCR texts, our .txt files, and I'll show you that in just a second. The next thing we're going to be working with is JSON. We're going to export our data as JSON data so that we can then use the script that we wrote in 2 videos ago and create kind of a text classifier in Spacy using the new Spacy 3.0 config system. Next, we're going to say from gensum.models, we're going to work with gensum here to do import word to vec. Word to vec is a very powerful way of representing a text as a series of words that each have a vector space. And I've covered word vectors a lot in this channel. If you're not familiar with them, check out those videos on word vectors or word embeddings, and you'll learn a lot from that. We're also going to just import gensum generally. I don't think I'm going to need it, but I want to import it like that just to be safe. Next, we're going to say from gensum.utils, we're going to be importing simple pre-process. Now, simple pre-process is a really good way to kind of pre-process texts in Gensum. It'll get rid of numbers. It'll automatically segment words out. It can lowercase everything for you. It gets everything in a really consistent format that we really want to see here. And in this video, I'm not going to be working with bigrams and trigrams. I'm going to give you the code necessary to do this. And if you want to include bigrams and trigrams, you can do that on your own with my previous videos. So that's what we're going to be really kind of importing. Now, for our files, we need to grab them all. And that's our first task, is to grab all of these 540 Holocaust testimonies, or oral testimonies. So we're going to say files is going to be equal to glob.glob. I have a whole video on the glob function, or the glob library. What glob allows for you to do is to grab everything from a directory. So we're going to grab them from OCR ***, which means anything that meets this criteria .txt, grab that. And the reason why we want to do that is because there are some .pdfs in that OCR category. So what we're going to say is for file and files, we're going to iterate over all of those files now. And this is important, at least if you're on a PC, you're going to say file is equal to file.replace, and you're going to replace the backslash with a /. That way you don't get an error when you try to open up the file. Next, we're going to say with open, and we're going to open up the file, and we're going to open it up as R, so make it readable. And then we're going to say encoding is equal to UTF-8. I don't believe that this is necessary, but I always try to do this just to be safe. And we're going to open it up as F. And our text is going to be equal to f.read. Now, if you look at these text files, you'll notice, and I've talked about this in a previous video, that segments, what I'm calling a segment, something like a question, something like an answer, in some case it'll have both question and answer, but everything is delineated, these blocks of text, by a double line break. I'm going to use that to segment my text up. Now, you might want to segment your text up based on punctuation, so periods, question marks, etc. That's fine. Go ahead and do that if you want to. Every corpora is going to be a little bit different, but you want to have something that is either a sentence or a few sentences for each segment, and those are going to be used for our training data. So let's go ahead and say text is equal to f.read. What we're going to do now is we're going to create the segments for each text, and we're going to do that by saying segments is equal to text dot split. We're going to use the split method here, and we're going to say /n/n, so any instance of a double line break. And then what we're going to do is we're going to take each segment for a segment in segments. So we're going to iterate over each of those segments, and we're going to say a segment is equal to, and we're going to call our simple preprocess function up here from Gensum. It's going to be equal to that, and we're going to say segment, and we're going to pass one argument to this. And it's going to be dac, which stands for deaccent, I believe. I'm pretty sure that's right. And we're going to run deaccent on this, and what that's going to do is it's going to clean up our text. And it's probably best if we just kind of show you what this looks like. So what I'm going to do is, I'm going to create an object out here called file. That's going to be equal to an empty list. And what we're going to do now is we're going to print off segment, just so you can kind of see what this looks like. And so we're going to just iterate over the first segment, and we're going to iterate over just the first file. And when we do this, you should see the segment printed out. And as you can tell, you're seeing it represented as a series of cleaned, very cleaned words. Fantastic. So what we're going to do is we're going to say final.append segment, and we're going to get rid of this so it can iterate over everything. And this is what Gensum expects. It expects something that looks like that. Once we have all these segments out, in fact, we probably don't want segments that are really large. So we're going to say if the length of segment is greater than 5 and the length of segment is less than, we don't want things that are too big. So 200 words and 500 words, anything between that range, we're going to just go ahead and append to file or final. And then we're going to work with some JSON functions that I always have in all of my scripts. They're really handy. Pause the video now, you can read them out, but chances are, if you've been following this series for a long time, you've seen me write these out plenty of times. What they allow me to do is just simply write data, and I can say that I want it to drop into demo segments.json, and we're going to do this, we're going to pass in final. So what this is going to do is it's going to iterate over all of our segments and then drop them into this JSON file. And once this is done, I don't have to go back and re-examine all of my segments. I can simply trust that these are going to be stored now as a JSON file that I can then load in the future. And this will take a second just to run. It's got to iterate over 540 oral testimonies and store everything. And it's already finished. So what I'm going to do now is I'm going to comment this out because I don't really need it anymore. And now I can do my data is going to be equal to, actually let's call it segments so we can be consistent, is equal to load data. And I'm going to load in my data underscore segments.json file. And just to make sure that everything is right, let's see how many segments we have to work with. Data underscore segments. Perhaps, oh, I called it demo underscore segments. Wonderful. There we go. And I've got 55,487 different segments that I can work with. This is great. So what I'm going to do now is I'm going to use that data to train custom word vectors on them. And I can do this by using our word2vec that we imported from Gensum. So I'm going to say model is going to be equal to word2vec. This is a really simple, I'm not going to be working with any hyperparameters. I'm just going to try to create a model based on these segments. And then I'm going to say min count is equal to 1. I'm not going to load up any workers right now because I don't want to introduce too many variables to you. This really isn't a tutorial on Gensum. I've got those in the past and I'll have more in the future. This is just a tutorial on how to conceptually use word vectors. So what we're going to do is we're going to save this, and we're going to call this demo.bin. So we're going to train it on these word vectors. And in theory, what's going to happen is these word vectors will be pretty well honed to these specific Holocaust testimonies. With 55,000 segments, with segments ranging from 5 to 200 words, I think we'll be able to get acceptable word vectors, not great ones. And our model is already done. So let's test out our model. There's a great way to kind of test out how your word2vec model looks. So we're going to say model is equal to word2vec.load. So we're going to load in the model that we just created, which I believe was called demo.bin. Great. And we're going to try to figure out how similar, or what words are similar to the concept of hunger. So we're going to create an argument here, or an object here called keyword, and this is going to be what we can change going forward. And let's call the model now and try to figure out what some good word vectors are. So we're trying to figure out the words that are most similar to the concept of hunger. And we can do this by saying model.wv, going into the word vectors, .similar by word. And this is going to allow us to run the similar by word method and figure out the top words, the top n, we're going to say 10, it's going to grab the top 10 words associated with the concept of hunger. So for item in res, we're going to print off item. And you're going to get a series of tuples here. And these tuples are going to be equivalent to a few different things. So here we've got hunger being associated with fear, tension. I'm not entirely happy with these word vectors. So I think what I'm going to do is I'm going to try to retrain our model and increase word count to 5. And in fact, I might just try to recreate new data and get rid of some of these rules I have up here. So this is a great example of looking at your word vectors, seeing results that don't really deal with hunger. And I'm going to go ahead and keep things that are quite long. I'm going to rerun everything essentially now. And hopefully what we get are better word vectors. And we'll see if this actually works. It should take a few seconds, probably about 30 in total to actually run. By rerunning this, I'm able to really quickly just kind of prototype a new set of word vectors to get a good sense. I know what I was looking at wasn't great because I know what the word vectors for this domain should look like. We should see concepts of starvation, and what you're going to be surprised at is in position 3 is a word like malnutrition, something that you might not necessarily think about as a concept of hunger, but dealing with it conceptually. Other things that you'll see pop up are things that deal with the concept of cold and the concept of sickness, like typhoid, deeper in the word vector space. But you'll see that in just a moment. Okay, now our model is done kind of retraining, and in fact we see these words represented much more like what I said. Starvation is high up, sickness is high up, the concept of thirst, I would argue, is exactly parallel to the concept of hunger, just a different experience of the same variety, right? Malnutrition, pain, dysentery, these are all things that are conceptually dealing with the concept of hunger, typhus, dying, etc. Now, how can I use this list? Well, let's print off a few more to get a broader sense. And what we can do with, let's cancel that. I don't need to rerun everything here because I've already got all this. And let's go back up and we're going to comment all of this out. Now this will run a lot more quickly. And so what I'm going to do is grab the top 20. And what I'm using these for is to kind of get a sense of some words that I can use to kind of search these segments. So I'm going to have a list of search words. And that's going to be equal to things like hunger, starvation, and both of these words give me, conceptually as a human, ideas of hungry, starve, starving, right? And then we can also deal with things like malnutrition. I wouldn't have thought of that initially. Diarrhea, I think we could argue, is conceptually tied to hunger. This is a common experience from dysentery, something I would not have necessarily thought about right away. Stench, we're not going to really include that. Diseases, typhoid, terror, beatings. So we're getting kind of broader ideas now, but we have a few good search words that we can use to kind of automatically start understanding when someone's talking about hunger. And I know from my past experience and conversations with Holocaust experts, excuse me, that things like potato and bread are oftentimes used to describe things like rations. These are all dealing with concepts of hunger or a lack of food or food that is given to those who are impoverished. So what can I do with this? Well, what I can say is I can go over all of my segments. So for segment and segments, right? I'm going to close this. And I'm going to basically iterate over all of these segments that I'm going to reload in. We're going to say for word in search words, there's a better way to do this, but I want to be very clear on how this is working. So we're iterating over all of the segments. We're iterating now over all the words in search words. If word is in segment, then we're going to say match is equal to false. If this happens, the match is going to be equal to true. So if it finds a word, then we alter that match. Otherwise, it's going to remain false. So if match is equal to true, then we know that that segment has one of these words in it. So what we're going to do is we're going to say segment is equal to dot join segment. And what we're doing is we're creating now a string that we can use. And we're going to, let's say something along the lines of, let's make this our training data. And we're going to say train data dot append segment. And for this, we're going to say, we're going to give it the number 1. We're going to say that 1 deals with hunger. Okay. Actually, let's just call this, let's leave it like that. We're going to say 1. So now what I can do is I can write, let's actually just print off train data 0. So we're going to grab our first hit. And we have a syntax error. What have I done wrong? If word is in segment, there we go. Load data is not defined. I must have commented out my JSON files, and sure enough I did. And because I know that this should work, I'm going to go ahead and write data. We're going to call this demo hungertrain.json. And we're going to pass in our train data. And what it's doing now is it's iterating over all those segments, and we've got, it looks like I don't know how to append a list correctly. We have to append a list as a tuple, not as 2 separate items. And so we have our first hit, and I'm kind of curious how long this is. We can look at that in a second. So had to take some food to help with starvation, so definitely dealing with the concept of hunger here. And we see that it is assigned this number 1. And it's grabbing, this isn't cleaned, remember. This is raw data that is not cleaned. Again, so you're going to have some odd things like this. But for the most part, you're getting a clear example of hunger training data. So let's go ahead and load in hunger train is going to be equal to load data. We're going to load in that demo hunger train.json. Let's get a sense of how much data we've actually got. So print ln hunger data. And it's going to do all the other stuff I just did a second ago. Let me just comment this out, because we don't really need that right now. And let's run this. Hunger train. Whoop. And what you should see is a good set of training data for hunger. And we've got a sample size of 2,772. So we've got 2,772 things that deal with hunger. And we know for a fact that they're going to deal with hunger because we've got kind of these really good search terms. So we were able to take the concept of hunger, just one word, and automatically use both our common sense knowledge, so words like these, to kind of create a basic list of words that are going to deal with hunger. And then we were also able to use these more abstract things that we might not necessarily think about. Concepts like malnutrition, diarrhea, dysentery, rations, bread, etc. to create 2,772 training data for that. Now, all you have to do is repeat this exact same process for another concept like smell. I'm not going to repeat it because there's not really a need to here. Instead, I want to kind of demonstrate quickly how this entire process can be easily replicated with another keyword. Let's look and see what the top hits with smell are. And you would repeat the same process, kind of select out those words that deal conceptually with smell. And this is going to be a good demonstration of word vectors and how they're different on a specific corpus. So stench, flesh, odor, smoke. You will notice right now off the bat that these are dealing with horrible, horrible, horrible concepts of smell. And that's for a good reason. The data set that we're training on is dealing with concepts that are naturally horrible, the worst experiences humans could possibly experience. If you were to use basic word vectors trained on a general corpus, you would see these these words be more general, a combination of pleasant and unpleasant experiences. But you can get a very good sense of these kind of sensory concepts associated with smell. Things like rotten that you might not necessarily think about in your initial training set or initial keywords for stench. So go ahead and repeat this same concept for other things that you would like to be included in a text classifier. And that's going to be it for this video. In the next video, we're going to kind of do what we did in video 0 or video 1 of text classification and use these new training sets to train a text classifier that can distinguish between concepts of hunger and concepts of smell. Thanks for listening. If you've liked it, please like and subscribe down below. And if you're looking forward to seeing where this is going in the future, let me know in the comments down below. And also, if you feeling generous, please do consider contributing to my Patreon, linked in the description down below.